All right, let's talk about one of the most powerful and, honestly, one of the most misunderstood tools you've got in your system design toolkit, Amazon's DynamoDB. And look, we're not just going to cover what it is. We're going to talk about how you can actually discuss it in a system design interview. The goal here is to turn this thing from just another database into a real tool that helps you absolutely nail that interview and land the job.
So, picture this. You're in the interview. The pressure is on. You've just been asked to design some massive, super scalable system, and then comes the big question. Which database do you choose? For a whole lot of high-scale applications, DynamoDB is a fantastic choice. But, just picking it isn't enough. You have to be able to defend why it's the right tool for this specific job. And that's exactly what we're going to break down.
Okay, before you can even think about designing a system with DynamoDB, you gotta learn to speak its language. It really all boils down to 3 core concepts. If you can nail these, you've built a rock-solid foundation for the rest of your interview.
First up, we've got the table. Now this is the easy part, right? It's a concept you're probably totally familiar with from the SQL world. A table is, well, it's just a collection of related data. So if you're designing a user service, you're going to create a users table. Super simple.
Next, we have an item. So inside that users table, every single user would be one item. Think of it exactly like a row in a spreadsheet or a SQL table. It's just a single unique record that represents one thing, one user, one product, one order. You get the idea.
And finally, attributes. These are the little individual data points that make up each item. So for one of our user items, the attributes would be things like user ID, name, or email. So let's just recap real quick. Tables contain items, and items are made up of attributes. Easy enough? Okay, now this is the first huge difference from SQL that you absolutely have to bring up in an interview. Get this, DynamoDB is schemaless. So what does that actually mean? It means not every single item in your table has to have the exact same attributes. One user might have an employer attribute, but another one doesn't. And this right here, this is a classic trade-off. You get this incredible flexibility, this amazing speed. I mean, no more of those painful database migrations, but, and this is the important part, you're shifting the responsibility of handling all that potentially inconsistent data over to your application code. Just being able to talk about that trade-off, that shows your interviewer you're thinking like a senior engineer.
All right, let's get into what is probably the most important part of any DynamoDB design. Seriously, your strategy for picking keys will either make or break your system's performance, and you can bet your interviewer will be paying very close attention to this.
The primary key in DynamoDB is this really clever 2-part system that's designed for massive scale. First, you've got the partition key. DynamoDB takes this key and runs it through a hash function to figure out which physical server or which partition your data is actually going to live on. This is the secret sauce to its horizontal scaling. Then you have an optional sort key. And what that does is it orders the data within that partition, which makes range queries unbelievably fast. Let's make this a little more real with some actual examples. Imagine you're building a chat app. Your #1 query is going to be, get all messages for this specific chat, right? So you'd pick chat ID as your partition key. Why? Because it guarantees all messages for one chat are stored together. Then, to keep them in order, you'd use something like a message ID that goes up over time as your sort key. Or how about an e-commerce site? You'd probably partition by user ID to group all of a customer's orders together and then sort those orders by order ID. Makes sense. And this leads us to a really, really important word. You got to remember this one, collocation. Seriously, using that word in an interview is like a secret handshake. It shows you get it. By partitioning by that chat ID, all the messages for that one chat are physically stored together. They're collocated. This means fetching them is just this lightning-fast operation on a single machine, not some slow scatter-gather mission across the whole fleet. When you say collocation, you're signaling to your interviewer that you understand how the data is physically laid out. And trust me, that is a huge plus.
So designing your primary key around your main access pattern is awesome for performance. But what happens when the product team comes knocking and says, hey, we need to look up the data in a totally different way? This is a classic interview question, and believe me, DynamoDB has a really powerful answer for it.
Let's stick with our chat app for a second. Our primary key is perfect for fetching a single chat, but now we need a new feature, a page that shows a user all the messages they've ever sent across all of their chats. Uh-oh. Our primary key is totally useless for this. We can't query efficiently by user ID. So, what do? This is the part that trips up a lot of people.
The answer is secondary indexes. And there are 2 main flavors.
Think of a global secondary index, or a GSI, as basically creating a whole new lookup table. It gives you a brand new partition key. So, for our problem, we'd create a GSI with user ID as its partition key, problem solved. Now, a local secondary index, or an LSI, is for when you actually like your partition key, but you just need to sort the data inside it differently. You know, like sorting messages by the number of attachments instead of by time. So remember, GSI for new access patterns, LSI for new sorting orders. So at this point, you've covered the basics. You've shown you can design a solid data model. Now let's talk about a few advanced features you can pull out of your back pocket to really show you have a deeper, more professional understanding of the whole ecosystem. These are your pro moves.
If you need a cache, please don't just say, let's add Redis. If you're using DynamoDB, the pro move is to mention DAX, the DynamoDB accelerator. It's a fully managed, in-memory cache that sits right in front of DynamoDB. We're talking microsecond response times for those really read-heavy workloads. It shows you know the specific tools for the specific platform.
Okay, what if you need to react to changes in your data, like in real time? That's where DynamoDB streams come in. This feature enables something called Change Data Capture, or CDC, and what it does is it lets you capture a real-time stream of every single modification happening to your data. A fantastic use case for this is keeping a search index, like Elasticsearch, perfectly in sync with your database. An item gets updated in DynamoDB, and a stream event instantly fires off a function to update that search index. It's brilliant.
Now this brings us to a common myth that you can totally debunk in an interview. For years, the argument was always, if you need strong consistency, you have to use a SQL database. Well, that's just not true anymore. While DynamoDB does default to eventual consistency, which gives you higher availability and lower latency, you can simply request strongly consistent reads for any query that absolutely requires it. It's a trade-off that you get to control.
So we've talked a lot about when DynamoDB is a great choice. But, a senior engineer knows that the most important skill is understanding the limits of your tools. Knowing when not to use DynamoDB is every bit as critical as knowing when to use it. So here are 3 big red flags to mention. First, if your design requires complex, ad hoc queries with a ton of joins, you know what? A relational database is just a better fit. Second, for systems that need complex, multi-table transactions, traditional SQL is often the safer bet. And finally, and this is a big one, if you find your design needs 5, 6, or 7 secondary indexes, that's a huge sign that you might be trying to force a relational model onto a NoSQL database. That's a massive red flag.
And that's where we'll leave it. You've now got the data model, you understand the performance keys, and you have the advanced tools in your arsenal. The next time you're in the interview, you'll know exactly when to pull DynamoDB out as your secret weapon, and, just as importantly, when to leave it in the toolbox. The choice is yours.